Welcome back to Summarize Science. Today, we're diving into one of the biggest puzzles in cosmology. How did supermassive black holes get so big, so early in the universe's history? These aren't just big black holes. We're talking about monsters a billion times more massive than our sun, seen when the universe was less than a billion years old. Growing that fast is a major challenge to our standard theories of black hole formation. A recent study used the incredible power of the James Webb Space Telescope to get our first look at the environments around two of the most distant quasars ever found. A quasar is the intensely bright region at the center of a galaxy, powered by a feeding supermassive black hole. The theory has been that these ancient giants must have grown in the busiest, most crowded neighborhoods of the early cosmos, giving them plenty of galactic gas to gobble up. To test this, researchers used the JWST to hunt for neighboring galaxies around two quasars from just 700 million years after the Big Bang. And they found them. Across the two regions, they confirmed the existence of dozens of other distant galaxies. This confirms that these quasars do indeed live in dense, overcrowded regions, which would provide the fuel needed for rapid growth. In one case, they found a galaxy that is incredibly close to its quasar, a mere 7,000 light-years away. This is a compelling candidate for one of the most distant quasar-galaxy mergers ever seen, a cosmic dance that fuels the central black hole. But as they analyzed the clustering of these galaxies, a much bigger puzzle emerged. By measuring the density of galaxies, they were able to estimate the duty cycle of the quasar. Think of the duty cycle like a light bulb that flickers on and off. The on time is when the quasar is shining brightly, and the off time is when it's dormant. Their results suggest that these supermassive black holes are only on and shining for about 0.1% of the time. That's an astonishingly short period, a flicker of activity lasting just a few 100,000 years. This is where the story gets really complicated. If the black hole is only actively feeding for such a tiny fraction of its life, how on earth did it grow to a billion solar masses so quickly? This finding dramatically shortens the time available for growth, making the original problem even harder to solve. The researchers suggest that this implies a radical new idea about how these giants grow. Most of their growth might be happening during the off phase, when the black hole is shrouded in thick gas and dust. In this scenario, the black hole is still feeding voraciously, but it's hidden from our view, making it an obscured quasar. The bright quasar phase we see might just be a brief moment at the end, when the black hole's energy has blown away some of the surrounding gas. So, let's recap the key points. Using the JWST, astronomers confirmed that the earliest quasars live in crowded cosmic environments, perfect for finding fuel. They even captured a snapshot of a potential galaxy merger feeding one of these black holes. But the most important discovery is that these quasars seem to flicker on and off, with their on time being incredibly short. This poses a major challenge to our understanding of black hole growth and suggests that for every bright quasar we see, there could be 1,000 more hidden behind a veil of gas and dust, growing in secret. This is just a first look with a small sample, but it opens up a fascinating new chapter in the story of our universe's first giants.